Um, I'm part of a GBS group in MEA region. This group is giving support to our premier customers, and with this, we have other webcasts for April, May, and June period. You can access all our webcast list via our blog on TechNet. All you need to do is type blogs.technet.com/MEAGBS, and you'll see our other webcast series about other topics: .NET, SQL Server, Windows, Link, Cloud, PowerShell, and all other sessions. Okay, let's start our session. Today I'll talk about our appliance solution for data warehouse application, parallel data warehouse. With recent announcements, we'll change our appliance to analytics platform system. You'll see why we become a platform. First, let's talk about traditional data warehouse. In traditional data warehouse, you have a central data warehouse system, and in this central data warehouse system, you load your data using ETL tools or ETL system from different systems. For example, your OLTP system, your ERP, CRM, or line of business applications. And after you're loading your data, you'll analyze your data using BI tools or analytics. You can use Excel, Power Pivot, or reporting server, or even analysis services to analyze your data. In the data warehouse landscape, for the last couple of years, the amount of data is increasing, and we need a different solution. I'll try to explain what PDW tries to solve. As I said, we are collecting more data and transferring more data to our data warehouse system. On top of that, the business workers need more real-time data, meaning that they need more faster access to queries, data warehouse queries. As you know, they are working on a big data set, and in a traditional system, it's when your data become larger, you'll get your performance decrease. And on top of that, we need other systems, like other requirements from the analysis part. For example, the business analysis require more recent data, more up-to-date data to the data warehouse in order to analyze trends in the sales or analyze user activities in social media as such. And because of that, we have new data sources like device data. For example, if you are a manufacturing system, you can collect your sensor data and analyze this data and adjust your manufacturing systems. Or you can collect data from social networks to see what your customers are thinking about you, or other companies that are mentioning about you. And on top of this, we also have new cloud systems that we are collecting data and analyzing this data using a data warehouse system. If you think of a traditional data warehouse system in terms of hardware and software, when you have more data, or when you need a more faster result set from your data warehouse system, what you do is you are forklifting your hardware. What I mean with forklifting, you are increasing your CPU, memory, or disks and other stuff on your hardware. what you do is you get rid of your old hardware and you replace it with a higher hardware, which you are spending more and more money on your hardware. And also at some point, even if you are willing to pay more money to a faster system, there's a physical limit on the number of CPUs that you can have, number of memory that you can have on a box. And because of that, we need a different solution than a scale-up solution. And other than that, we on traditional data warehouse, we are storing our data in a row-based, meaning that all your data, all your records consist of a row, including all the columns in that table. And in terms of analysis your data, you are not requiring not all your columns. You need some. You usually use subset of columns, and when you get that data from row store, since it is stored in a row-based, you get all other columns that you don't need, which means you have to do more I/O on your storage system, and it also take up more buffer pool on your memory. As I said, we need a different solution, and for this we need a scale-out solution. What I mean with scale-out solution, you start with a simple hardware, which includes a couple of servers and dedicated storage for that servers. And when you need more data storage, or when you need more processing power, all you need to do is you add more servers or more storage to your system. Meaning that your existing hardware stays. All you do is you add additional hardware to your system, and every node in scale-up solution, all the queries share same CPU, same memory, and same storage I/O path. In scale-out solution, everything is dedicated. All the servers are dedicated to a storage, and all the queries running on individual nodes, they are using a dedicated CPU, memory, and disk I/O path. You can add additional nodes, scale units to your system, and you can even add additional racks to your system. This allows you to have more data space, up to 6 terabytes in our implementation of MPP solution. And let's continue. We'll talk about HD Insight in coming slides. Okay. Our analytic platform system includes enterprise-ready big data processing. What I mean with enterprise-ready, you have both relational and non-relational data crunching in a single appliance. And for relational data analysis, we use SQL servers on the behind in each node. We'll go into deep. And for non-relational data, it goes to the Hadoop cluster. What this analytic platform system does is it integrates both Hadoop and relational and non-relational data, and you use your existing skills. You just use your existing T-SQL skills without worrying about how to query a Hadoop system, etc. And you have, as I mentioned, you have a scale option. You can add additional nodes to your system in terms of storage and processing power. And we have other systems like in-memory column store, which we'll talk about in coming slides. And MPP system, what I mean is MPP is massively parallel processing. What you do is, instead of querying your data from a single computer, what you do is first, you divide your data to different computers, and when a query comes to your data set, the control nodes send this query to individual compute nodes and gather the result set and return it back to the query request. And we'll talk in detail on how it works as well. And this is marketing stuff. In terms of cost per terabyte, we are the lowest in the market currently. And we'll talk about how hardware and software shape in coming slides. When we said we have an appliance solution, as you can imagine, appliance consists of both hardware and software. The power of an appliance is both hardware and software are tuned, taking care of what the current hardware settings and what is the software running on top of that hardware. And it is highly tuned for that system. And we are working with the 3 different hardware vendors, Dell, HP, and Quanta. And what we do is we are working with this hardware vendor, and we are using a reference architecture. As you may know, we have in the past we have a reference architecture for OLTP systems that you can build from a hardware vendor. And the idea is same in here. We have, as I said, a reference architecture. When you give an order for PDW, depending on your sizing requirement in terms of storage or processing power requirements, the factory builds that hardware from a predefined hardware, predefined server models, storage models, InfiniBand systems, etc. And it will be installed a pre-configured software on top of it. And it will ship to your system. All you need to do is you plug it to your system and start using it. Okay. Let's talk about how hardware it looks like. As I said, we have a standard hardware, and it is off-the-shelf servers and storage. For server side, we have 16-core Intel processors and 256 GB of memory. And since this appliance works on top of different computers working together, we need a high-performance interconnection between compute nodes and the control nodes. Because of that, we are using an InfiniBand network for data movement. And in order to reduce cost, we are an optimal cost, not reduced, an optimal cost. We are using just bunch of disk system. And for backup landing zone, we have a reference that you can build your own. And we also have a concept of base unit, scale unit, and passive unit. Let's see what these are meaning. You start with a single rack, and single rack comes with a networking. We have 2 kinds of network, an InfiniBand network and Ethernet network. And as you can see, both these networks are built on top of high availability thinking, meaning that we have 2 switches. If something happens to one of switch, another switch will continue on working. And we have 2 networks, InfiniBand and Ethernet. InfiniBand network is for data movement within the appliance, and Ethernet network is communication and control messaging within the appliance. And on a base unit, I mean, you start with a quarter rack or 1/3 rack, depending on the hardware vendor. And let's say you start with a quarter rack. When you start with a quarter rack, you start with a 1 control node and 1 failover node, and 2 compute nodes, and a JBOD connected to these compute nodes. This called its base unit. Scale unit is adding on top of this infrastructure what you can do is you can add a scale unit. This scale unit can be HD Insight region or PDW region, depending on your needs. And you increase your number of compute nodes that you are crunching your data. And after one full rack, you can add additional racks to your system. In additional racks, depending on your choice, you can add both PDW region or HD Insight region in your appliance. And passive unit, as you can see, we have failover nodes in both racks, and these are the units that these are the nodes that allow you to have high availability within the appliance. And we'll talk more detail how it works in coming slides. Okay. In terms of storage architecture, as you can see from the previous slide, every two nodes, for example, this is an HP implementation, every two nodes have a dedicated storage. Dedicated storage is JBOD storage, and it is SAS connected between nodes and the storage. And as you can see on node 1 and node 2 using storage 1, and as each storage, for example, these storages have 70 disks in it, and from the 70 disks, 4 are hot spares, and each node use a mirroring setup. What I mean with mirroring setup, when you check the hardware of JBOD, you'll see that it consists of two trays of disks. What we are doing is we are creating a mirroring between these two storage these two disks. What I mean is, let me draw. As you can see, node 1 is using disk highlight disk in red. What we are doing is we are mirroring two disks to each compartment within a storage. This allows us to have high availability in a storage side. And since we are sharing a one JBOD with two servers, each server have a dedicated disk for them. For example, for node 2, it's using a yellow color disks, which are mirrored between the between each part of the JBOD. This is the storage, and let's continue with software architecture. This is V2 software architecture, and we have a new version of our V2 appliance update 1 on top of VU hardware. In appliance update 1, we have another region called HD Insight, and we'll talk about in detail, but the idea is same shown in this picture. We have our appliance, and this dark colored rectangle represents our PDW. And within the appliance, we have three parts. We have a down-level failover clustering, Hyper-V, and storage spaces, which gives us hardware layer. And on top of it, we have appliance system, which consists of our fabric layer. And on top of it, we have a PDW engine, consists of control node and the number of compute nodes depending on your hardware system. And within the PDW system, we also have a management node, which we'll talk about in detail in coming slides. All these servers, you see, each node consists of a server. These servers use Windows Server 2012, both in physical servers and virtual servers. And In order to have high availability, we are benefiting Hyper-V virtual machines failing over between physical computers. And on compute nodes, in order to store our data, we are using a special build of SQL Server for PDW. And within the appliance, as I said, for data movement, we have DMS service, which is responsible of movement within the data movement within the appliance. And the control node is the one node that you actually see from the outside, which have the MPP engine, the main engine of parallel data warehouse. And what you have outside the appliances, you have query tools. We are using SQL Server data tools for accessing PDW, similar to SQL Server Management Studio. You can use command line tools, SQL CMD, you can use integrated services, or you can use link server from your standard SQL Server to connect to PDW. We also have business intelligence tools, I mean analysis services, reporting, Power Pivot for Excel. And for data loading, you can, in the previous implementation, the first implementation of PDW, the version 1 hardware and version 1 software, the loading and backup servers were a part of PDW appliance, meaning that we have a dedicated server for backup and dedicated server for data loading. We had this because in order to load data faster, and in order to take backup faster, you need to take benefit of InfiniBand network within the appliance. And because of that, we included backup and loading servers in the V1 hardware implementation. And we received numerous feedback from customers saying that they want to use their own backup system, they want to load data from different systems. And because of that, we removed the link between we remove the landing zone and backup to outside the appliance in order to give customers flexibility. And because of that, you can now load your data from different servers directly to the PDW using DB loader or integrated services. And you can take your backup to any system in your environment. All we need to do is a Windows file share to taking backups. And you can do a remote table copy. For example, you want to aggregate a data, and you have a small department which have many analysts. They are analyzing data. And in order to spread the workload of your system, you can use hub and spoke system, meaning that you can use the departmental SQL server and put some analyzed data to that SQL server, and your analysts work on it. And you can use remote table copy to move out of data from PDW. And we have SCOM integration in order to monitor your system. And for non-relational data, we have Hadoop. You can use a Hadoop cluster to query data using Polybase system, which we'll talk about in coming slides. And let's talk about a concept that is the heart of the PDW appliance. This concept, we call it regions. A region is a logical container which consists of a defined hardware system, including servers, part of server, CPU memory, amount of that server, and the storage and the network infrastructure. Why we use regions? Because we want to run different workloads within the appliance. In the first two implementation of PDW, we had only parallel data warehouse workload. And with the new appliance update 1, we also have now HD Insight workload. let's see what I mean with the workloads and the regions. You can think the PDW appliance as small cloud implementation and implementation of infrastructure as a service. What I mean is, as you know, for infrastructure as a service, you have to put different layers on top of hardware, and the workload, the real application that you want to run on the hardware is agnostic of the hardware. Which, what I mean agnostic, it can work on not a dedicated server, on any server within that infrastructure as a service. Let's see, we have, as I said, Ethernet and InfiniBand network, and on top of it, we also have our storage. We are using JBOD, and we have storage attached servers. And for example, for this one, this is a hardware representation of half rack. In half rack, we have 4 compute nodes, and all the compute nodes, all these servers are directly attached to storage, and we call them storage attached servers. And we also have non-storage attached servers, which we run our other infrastructure machines. And this consists of our hardware layer. And as I said, we want to run our application, and we don't want to keep a hard tight between hardware and software. And in order to have this ability, we need an additional layer on top of hardware layer. And for this, we have fabric layer. Fabric layer is consists of basically a Hyper-V cluster, which allow us to run our virtual machines on top of this hardware layer. And our virtual machines can run on any servers, or can use any network interface for high availability. In Fabric, in order to have this closed system, we have an Active Directory. This Active Directory is we are using this Active Directory in order to manage this hardware and some infrastructure virtual machines. From now on, all the computers, all the servers that I show, including this Active Directory, they are virtual machines. All the physical hardware stays in the hardware level. And since we are using virtual machines in order to run our workloads, we have a VMM computer, a virtual machine manager, in order to provision virtual machines and other stuff related to Hyper-V. And on top of this Fabric, now we can run our workloads. And our workloads can consist of different systems. In this implementation of PDW, new name is Analytics Platform System, we have 2 workloads. We have PDW workload and we have HD Insight workload. And each workload works in a silo, meaning that they are not sharing any resource with the other workload, and they are working in a closed system. And because of that, we have a management node in PDW workload, which includes another Active Directory and some management software on it. And we have a control node. This is the PDW engine running on, and you are connecting to this computer to run your queries. And we have compute nodes that is directly working on our data. And for HD Insight, since it is a different workload and it needs to be self-contained, we have a management node which includes another Active Directory. And we have a head node for Hadoop and security node for connecting using your Active Directory credentials. And data nodes running on virtual machines as well. And this is a conceptual view. And let's see how it looks like on a physical rack. And we also have iSCSI virtual machines. Since we are using JBOD and mirroring fashion, and we are able to fail over different computers, we need these tiebreaker computers in the environment. Okay, this is how it looks like on a rack. As you can see, we have at the bottom we have one scale unit which consists of a storage and 2 servers, and we have additional scale unit which consists of another storage and 2 compute nodes. And on top, we have Ethernet InfiniBand switches, which shared within this rack. And we have non-storage attached servers on top, which runs our engines and infrastructure services. And as you can see, we have 2 empty nodes here, HST02 and HST04. And these are the failover nodes for virtual machines. For example, if something happens in one of the virtual machines on HST01, what the system does is it failover all those virtual machines to our failover node to HST2. And let's say if we have we have a problem with PDW part of the, for example, we have problem with HSA02 hardware problem. The system is automatically failover that compute node to HST02 as well. As you can see, for PDW and infrastructure virtual machines, HST02 is our failover node. For HD Insight machines, HST04 is our failover node. When something happens to head node or security node or management node, or HST03 has a hardware problem, these virtual machines are failover to HST04. And it would same as for data node for HD Insight as well. Okay. At the beginning, I mentioned that we have some other system other than the MPP infrastructure, massively parallel processing infrastructure. We have also column store index. In order to, as I said, in the traditional data warehouse system, when you use row-based system, you query all the columns that in that data set. However, in data warehouse system, you are more involved with or more query on not all the columns, but some of the columns that you do some average or min-max analysis on that columns. We are using a column store index. You can use both column store index or traditional clustered index in PDW, but in order to get benefit of high performance, it is suggested that you move to your tables to column store based storage. And for MPP, as I said, we have a control node here, and we have compute nodes which have dedicated storage at the behind. When you run a query on PDW, and it query in a parallel. What I mean is, when a query comes to control node, it query to the compute nodes, it gathers the data, and it returns back the result to the user. Since we are dividing our data and query load to different computers, the performance is much higher than the traditional SMB system in compared to MPP system, massively parallel processing system. And as I said, we were using a special build of SQL Server 2012 in Parallel Data Warehouse, which has updatable column store index. Updatable column store index now part of SQL Server as well with the SQL Server 2014. But we were using the updated column store index for the last 1 year in our PDW system. How it works is when you load data, it divides your data in row groups. And when a row group reaches 1 million records, it's converted to the column segments and compressed it to each segment to a smaller size in the storage part. And when you have additional rows inserted or added to your system, they are storing in a data store. Data store is traditional row-based data storage, and what the system does is when you query data, both column store data on the storage side and data store combine together and return back to the query as a query result. In a bulk insert scenario, when you are inserting 100,000 rows, each 100,000 rows become a column store. But in a normal working condition, when a row group reaches 1 million records, the system converts it to column segments and stores a column store index. And it's done it behind the scenes without you noticing. And as you can see, we have insert, delete, update, and select statements. All the insert directly goes to data store, as I said. When data store reached 1 million records, the system automatically converts the column segments and to column store representation, and it creates a new data store for new data insert. Delete operations are logical deletion on column store, part of the column store index. When you rebuild your column store index, it gets rid of deleted records from that column store. Update is, as you know, delete followed by insert. First delete data and insert new data. And as I said, select unified both column store and row store data using a union operator. In PDW, we have two kind of table concepts. We have distributed table and we have replicated tables. If you think of data warehouse implementation, you have lookup tables, which we call dimensional tables. What you do is typically this kind of tables used in the joins almost all the queries, because they are lookup tables and you have to present instead of product ID, you have to present the product name or those kind of things. And you also have big fact tables in your data warehouse implementation. Fact tables means, for example, your sales, and they are take up almost 80–90% of the data space in a typical data warehouse implementation. And let's see what we mean with replicated and distributed tables. For example, your dimension tables, as I said, they are using in all the joins. And in the beginning, I mentioned that in the MPP architecture, the main concept is share nothing architecture. Share nothing meaning you are not sharing storage between compute nodes. You are not sharing CPU and memory between compute nodes. And since your dimension tables go into the almost all the joins, what you do is you replicate these tables to each compute nodes. Because they are small in size and they are not taking too much space, it is not taking, as I said, too much space on your system. And since they are available in each compute node as a whole table, there's no data movement, and they are used in the joins within that compute node without requiring data from other compute nodes. On the other hand, for distributed table, you have one big fact table, and you divide it into chunks. And what you do is you send each part of this table to a different compute node. And when you run a query, each part, depending on your query predicates or joins, each part run within that compute node. And if data required on other compute nodes, data are moved within the appliance using InfiniBand network. The depicted here is in red arrow. And all the query run within that compute node. And result return back to the control node for the client. And let's see how query runs on a PDW system. When you create your user databases, as you can see here, your database is created on a control node and each compute node. However, the database stored in the control node is a shell database, meaning that there's no data in it. It is just metadata and the statistics data for the better query execution plan generation within the PDW. And a compute node, all your data is stored on compute nodes, and each compute node has some part of the actual user data. And in order to query all your data for that database, you have to send query to each compute node and gather data on the control node. This is how it looks. When we receive a query from a query tool, it goes to the PDW engine. And what PDW engine does is, as SQL server, it parses the T-SQL query. And it checks for syntax error and other stuff. And then it validates and authorizes the query, meaning that the person who sent the query, does he or she have accessed that table and or that SP, that kind of stuff. And it's done by using a master database on control node. And then PDW engine creates MPP plan. MPP plan is the similar to query plan, but it is parallel execution plan, meaning that the PDW engine check the query, check the tables, which tables are joining, and what is the predicates. And depending on the table distribution, it knows which part of the table is stored in which compute nodes. It creates an individual standard T-SQL execution, T-SQL commands to be run on individual compute nodes. And these are normal, and then those SQL commands run within that compute node. As you can see, within each compute node we have a standard SQL server, and when the compute nodes receive a query from the MPP engine, PDW engine, those queries are normal SQL server queries, and that query runs within the compute node as if it's a standalone SQL server. And PDW engine knows which queries to send which compute nodes and what to expect from the compute nodes. And it sends that execution to the compute nodes. And if data movement is required for that query, satisfy that query within each compute node, data movement service kick into place, and what it does is it checks, it gathers the required data from other compute nodes and move that data to that compute node which is running the actual query. And data movement service also work on the moving data from compute nodes to the control node as well. And query sent to user data, it works in, as I said, within each compute node, depending on number of compute nodes that you have. And it returned back to the PDW engine to control node, and it's returned to the user as a result set. Okay. Let's look at what are the new features and improvements with Appliance Update 1. So far, what I show is more like a version 2 hardware and software implementation. I also talk about HD Insight within that slides, because now we have new hardware requirements and new regions and new workloads. Now let's talk about what the individual new features in with AU1. First of all, we have HD Insight workload, as I show in the previous slides. And we have poly-based improvements. And we'll talk about poly-based improvements in the next slide. And we also have enterprise integration. In the previous implementation, in order to log into PDW engine, you have to use SQL Server authentication. With the AU1 update, now we are supporting a federated solution, meaning that if you create a trust relation between your Active Directory and PDW appliance Active Directory, your users can use their existing Active Directory accounts to access the PDW. And we also enable to transfer data encryption, which allow you to store your data encrypted on the disk subsystem. And we have other performance and expansibility and servicing improvements. For example, in the previous implementations, data loader, DB loader tool loads data using control nodes. Now, DB loader works directly to the compute nodes, which increase our loading performance. We have some expansion options. We have add unit. As I said, we now have HD Insight workload, and add unit is allow us to add additional hardware and allow us to implement HD Insight to existing appliances. We also have some servicing improvements. For example, in order to change your IP settings within the appliance, it is now more streamlined and more faster implementation. As I said, in order to query non-relational data on a Hadoop cluster using standard T-SQL statement, we need an intermediate layer. And the polybase is our intermediate layer. What it does is, when you submit a T-SQL query to an external table, meaning that an Hadoop table, what it does is it converts your T-SQL query to a Java queries and send it to the Hadoop cluster. And with the new HD Insights region within the appliance, polybase also enhanced in order to support both within appliance Hadoop cluster or external Hadoop clusters like your Unix Hadoop cluster or Microsoft Azure HD Insight cluster that you can directly query using a polybase system within the appliance. And another improvement with the polybase is now we have predicate pushdown. Predicate pushdown meaning that in the previous implementation, when you query a Hadoop table, an external table, what polybase does is it queries that data from the Hadoop and it moves that data to the PDW engine and run predicates using PDW engine infrastructure, meaning that you can join both external tables and internal relational tables as if they are a relational table in one query. With the new improvement, what it does is it sends it queries table, for example, Twitter table in this example, and it applies column filtering, which columns you need instead of all the columns. And it also pushed down, as I said, the predicates, row filtering, meaning that only rows. Actually, what it does is it sends this query to the Hadoop cluster, and it filters data within Hadoop, and then move the data to the PDW engine, to a small set of data to the PDW engine in order to benefit query performance on that respect. I try to connect to actual appliance to show how it looks like. However, both VPN connection and this webcast connection didn't work together, and because of that, I will show you some dashboard views, how it looks like on a control node on PDW. I'll go quickly over it, and I'll take your question afterwards. Okay, when you connect to appliance, this is the home screen that you'll see. As you can see, we have an appliance. This is our fabric layer, and our parallel data warehouse and HD Insight layers on top of it. And if you go into the parallel data warehouse tab, you'll see similar things as appliance. You see your queries. These are more related to the parallel data warehouse implementation, because in your parallel data warehouse workload, what you do is you send a normal T-SQL statement to your parallel data warehouse. And because of that, we have a queries view, sessions view. When you load your data, you can monitor your data load from the loads. You can take backups, and you can check health status of the parallel data warehouse. Let's see what we'll see in individual parts. For example, in the sessions, you'll see all the sessions come to your appliance. And you'll see, if you click on the arrows in sessions, you see which queries come to that session. And on the queries part, you'll see the query list, all the queries that you received on your appliance. And as I said, if you click on the arrow, you'll see the MPP plan, execution plan, meaning that which compute nodes are queried for individual queries, what is the data movement between the compute nodes, etc. You'll see all the MPP execution plan from this query window. And if you have nightly loads, or you have loading your data, for example, every half an hour in order to have the new real-time data analysis, you can monitor your loads from the loads view. And you can check your storage, how much data, which databases have how much data is used. The one thing I mentioned here, all your data is stored as compressed by default, and also when you store your comp store index, you have more compression, and meaning that you use your storage space more effectively. And when you go into the HD Insight part, in the home screen, you see HD Insight related things. HDFS, what are the HDFS details within your appliance, and may produce job slots, job tracking, and also storage part of your virtual machines, or how much OS taking place, how much data is taking place. Okay, this is all. Do you have any questions? Or do you want me to repeat some slides in order to better understand? While waiting, I'll return back to the first thing that I show up. As I said, we have a blog website hosted on TechNet blogs. When you go into that website, you can see our upcoming webcast. For example, this Thursday we will have Windows Communication Foundation Data Services 5 related webcast. And in terms of SQL Server, since most of the people attending this session related with SQL Server, we have in-memory database coming up, and we have how to implement partitioning, performance monitoring using DMVs, and column store indexes in details, always on available groups, and these are the webcasts for coming months. Okay, I'll wait a couple of minutes if someone have questions, 5-10 minutes more, and if nobody asks any question, I'll end session. I received a question. Do you recommend some other source to read more about PDW? Unfortunately, we does not have that much public information available because this appliance is selling in a this system is selling in an appliance base, and when you buy the appliance, you also receive support, dedicated support for that appliance, which includes a dedicated engineer assigned to you. And from that on, after you get that service, a dedicated engineer give you the additional data and internal workings of the PDW as well. And he or she will work with you to implement PDW in your environment. I received another question. What happens if you need to restore data which was deleted in distributed databases? This is same as SQL Server. When you delete your data, and if you don't have any backup, if you have backup, you can restore from backup. If you don't have backup, you need to load it from the source as if you are loading first time. This is the same as SQL Server. Okay. Do you have any other question? Seems we don't have any other question. Thank you everyone for attending. As I said, you can check our blog post to see our upcoming webcast. And if you have any question, you can send me an email and I can try to answer your question. Thank you very much.